we know that integration is the reverse process of differentiation. Like if we differentiate x square minus 3x, then we will get twice x minus 3. And if we integrate twice x minus 3, then we will get back x square minus 3x. Therefore, there is a correlation between the formulas of differentiation and integration. In this video, we will learn how to derive the integration formulas from the differentiation formulas. The first rule is if we take derivative of any constant c, then we get 0. Therefore, if we integrate 0, we should get back c. So, integration of 0 dx equals to c. Second rule is the power rule, that is if we take derivative of x to the power n, then we get n times x to the power n minus 1. Therefore, if we integrate this term, then we should get back x to the power n. So, integration of n times x to the power n minus 1 dx equals to x to the power n. Now, replace n by n plus 1. Then we will get this line. And after simplifying, we will get integration of x to the power n dx equals to x to the power n plus 1 divided by n plus 1. This is the formula for integration of x to the power n dx. Next rule is d dx of e to the power x equals to e to the power x. So, if we integrate e to the power x, then we get back e to the power x. This is straightforward. Next one is d dx of ln of x equals to 1 over x. So, if we integrate this one, we get back ln of x. So, integration of 1 over x dx equals to ln of x. d dx of a to the power x equals to a to the power x ln of a. Therefore, if we integrate a to the power x ln of a, we should get back a to the power x. So, integration of a to the power x ln of a equals to a to the power x. Now, if we divide both sides by ln of a, then we get this formula. And this is the formula for integration of a to the power x dx. For trigonometric functions, we know d dx of sin x equals to cosine x. So, if we integrate cosine x, we get back sin x. That is, integration of cosine x dx equals to sin x. Next rule is d dx of cosine x equals to negative sin x. So, if we integrate negative sin x, then we get cosine x. So, integration of negative sin x dx equals to cosine x. Now, if we divide by negative sign, then we get the formula for sin x. That is, integration of sin x dx equals to negative cosine x. The same formula. Next one is d dx of tan x equals to sec square x. So, if we integrate sec square x, then we get back tan x. That is, integration of sec square x dx equals to tan x. Next one is d dx of cotangent x equals to negative cosec square x. So, if we integrate negative cosec square x, then we get cot x. So, negative cosec square x dx equals to cotangent x. And if we divide by negative sign, then we get this formula. d dx of sec x equals to sec x tan x. So, if we integrate sec x tan x, we get back sec x. So, integration of sec x tan x equals to sec x. Last one is d dx of cosec x equals to negative cosec x cot x. So, integration of negative cosec x cot x equals to cosec x. And after dividing by the negative sign, we get the formula for integration of cosec x cot x, which is negative cosec x. For inverse trigonometric functions, we know d dx of sin inverse x equals to 1 over square root of 1 minus x square. So, if we integrate this one, we get back sin inverse x, sin inverse x. And instead of 1, if a, then formula will be sin inverse x divided by a. The proof is given here. Next rule is d dx of tan inverse x equals to 1 over 1 plus x square. So, if we integrate this one, we get back tan inverse x. If you have any other constant a, then the rule is 1 over a tan inverse x divided by a. The last rule is ddx of sec inverse x equals to 1 over x times square root of x square minus 1. And if we integrate this one, we get back sec inverse x. And instead of 1, if we have another constant a, then the rule is 1 over a sec inverse x divided by a. For differentiation, the product rule is ddx of uv equals to u times dv over dx plus v times du over dx. So if we integrate this one, we should get back uv. So integration of that term equals to uv. Now if we cancel dx with this one, then we get integration of u dv plus integration of v du equals to uv. So integration of u dv equals to uv minus v du, which is the formula for integration by parts. Next rule is the chain rule, that is ddx of f of gx equals to f prime of gx times g prime of x. And if we integrate this one, then we get back that one, which is the substitution method. This slide is for special type of integration formula. The formula is for any function f, if you take derivative of the denominator and get the numerator, then its integration will be ln of the denominator f of x. For example, if you take derivative of x square plus 1, then we get the numerator twice x. So its integration will be ln of the denominator x square plus 1. The proof is given here, but you can directly use this rule. Next rule is integration of tan x dx equals to negative ln of cosine x. Why? Because tan x we can write as sin x over cosine x. And if we take derivative of cosine x, then we get negative sin x. So if we integrate the whole things, then we get negative ln of the denominator cosine x. Next one is integration of cotangent x dx equals to ln of sin x. Cotangent x we can write as cosine x over sin x. So if we take derivative of sin x, then we get cosine x. So its integration will be ln of the denominator sin x. Integration of sec x dx equals to ln of sec x plus tan x. To prove this, I multiply both numerator and denominator by sec x plus tan x. And after simplifying, I got this line. So if we take derivative of the denominator, then we get the numerator. The integration will be ln of the denominator sec x plus tan x. And the last rule is integration of cosec x dx equals to negative ln of cosec x plus cotangent x. So to prove this, I multiply both numerator and denominator by cosec x plus cotangent x. And after simplifying, I got this line. And if we take derivative of the denominator, then we get the numerator. So its integral will be negative ln of cosec x plus cotangent x. Thanks for watching.